Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 3197. Find the minimum area to cover all ones 2. So this is hard level problem marked by LeetCode. Let's read the problem statement. You are given a 2D binary array grid. You need to find 3 non-overlapping rectangles having non-zero areas with horizontal and vertical sides such that all the ones in the grid lie inside these rectangles. We have to return the minimum possible sum of the area of these rectangles. Note that the rectangles are allowed to touch. Alright, so problem statement is very easy. So we have to find 3 non-overlapping rectangles having non-zero areas with horizontal and vertical sides. And we have to make sure that all the ones in the grid lies inside these rectangles. So see this example number 1. Grid is like this, 1 0 1 and then 1 1 1. All right, so here this is my row 0, row 1. Here this is my column 0, column 1 and column 2. Okay, so now here in this example I can form 3 rectangles like this. If I make one cut here, right, and if I make one cut here, so this is one rectangle, this yellow colored, this is one rectangle, purple colored, and this sky blue color is one rectangle, right, this part. All right, so now here for this purple color, if you see 2 rows, right, and one column is there, so area of this rectangle I can say is nothing but 2, right. Same way for this yellow color, 2 rows are there and single column, so area is nothing but 2 into 1, that is nothing but 2. Done. And for this sky blue color, 1 into 1 I can say, right, 1 into 1, right, so this is nothing but this is equal to 1. So here if I just do the sum of all these, 2 plus 2 4 plus 1 5 is my output. So the ones at 0 0 0 0 1 0 are covered by a rectangle of area 2. The ones at 0 2, this one 1 2, are covered by a rectangle of area 2, and the one at 1 1 is covered by a rectangle of area 1. All right, clear. So here see, we are able to make 3 non-overlapping rectangles, right, and we have covered all the ones, we didn't skip any one, right. So here let's suppose if this is my rectangle, all right, and let's say I place my one here and one here and one here or one here, right. Now if I take this as one rectangle, let's say, okay, and let's say if I take this as my one rectangle, right, and let's suppose if I take this as my one rectangle, so here in this complete rectangle there are total 1 2 3 4 5 ones, right, 5 ones are there in total, and in these white color rectangles that I have formed, in total I have formed 3, so I am covering all 5s, right, so that simply means that this is valid. But let's suppose there is one more one here. Now you are able to form 3 rectangles but you are not covering all ones, then this is a invalid rectangle. Okay, this is one thing. All right, now here after this, let's suppose okay, so how you are going to make the cuts in the rectangle so that you can get total 3 rectangles in total, right. So how you are going to do that, so now let's understand that. Okay, so here there is one way to make 3 cuts like this. So let's say you make one cut here like this, right, and bottom part you divide it in 2 parts. Let's say this is one and the remaining is one, right. So in this way, okay, so here let's say this is starting from here, right, this is one way, right. So this is like this one part and then this one part and then this one part. All right, so here in this diagram if you see, I'm covering all the area, right, I'm covering all the area of this rectangle if I make the cuts like this, right. Or I can also do one thing like this. Let's say this is one cut, this is one cut here, and let's say this is one cut. So here also I'm covering all the area of rectangle, right, if I make the cuts like this. So I can say that these are nothing but horizontal cuts, right, like this, horizontal cuts. right? So I'm making two horizontal cuts, right? One here, and I'm able to get the three rectangles. All right. Now here in this case, I am making one horizontal cut, right? And I am making one vertical cut like this. So this horizontal cut that I'm doing here, this is covering the complete part, complete above part, right? And this side is covering all this part, and this side is covering all this part, right? So here also I am forming three rectangles in total. Is there any other way that you guys think of other than this? Can I make three rectangles? I want to cover all the areas, right? Here I'm covering all the areas. If you notice, this I cover all the areas, right? Here also complete this, complete this, complete this. All right. Okay. So yeah, there is one more way. There is one more way. If you do like this, here this complete, and then this complete, right? This is one more way. So in this way also you are going to make three cuts. So 1 2 3. In this also, let's say 1 2 and 3, and here also 1. Okay, complete this, and second is in between, and third is here, right? Total 3, right? Here also total 3 are there. Okay, now this is these are the total three ways that I think of right now, right? Only these three ways horizontal. All right, so now you may think that why I'm doing horizontally, I can do it vertically as well, right? This is what also valid, right? I can do it vertically as well. I can make cuts like this, right? This is also one more way, vertically, right? This part, then this part, vertically, this. Okay, and also if we discuss about vertically, then also we can do it like this also, this part, and then this part, and then this part, right? Or this complete part, right? And here second part, and here let's say third part. All right, so this way also we can do vertically, 1 2 3. Let's say this is 1 2 and 3, and let's say this is 1 2 and 3. Okay. We can do like this also, right? Now here, if I do one thing here, let's say I copy this complete. Okay, I copy this complete here, copy this. Now what I'm going to do here, let's compare this, let's compare this with these ones. Okay, bottom ones. All right, so now let's compare this with these ones. Okay, so here 2 3 and 1, right? And this is original form, right? If you see, this is the original form, original form. Let's say this is original form, and this is a new form that I formed, let's say like this. All right, so now if I rotate this, if I rotate this by 90 degree, then what will happen if I rotate this by 90 degree? So if I'm going to rotate it by 90 degree, this is going to move to this direction. Okay, this, right, bigger one. And let's say here my 2 goes, and here my 3 goes. Okay, so now this is similar like this one only, right? Same way, if you rotate this, let's say original, and let's say this is new. Okay, so if you rotate this by 90 degree, then you are going to get like this only, 1 2 and 3, if you rotate it by 90 degree. Clear? Same way here, this is your horizontal. If you rotate it by 90 degree, right, let's say this is a new one. So now if you rotate it, you are going to get like something like this only, right? 1 2 3, right? So what I'm going to do here, we know that we can do the partitions like this. This is one way to do the partitions, right? 1 2 3, this is one way. Or this is one way, one bigger here, 2 and 3, and this is one way horizontally, right? I'm going to write the code which is going to help me to solve like this, right? And what then, once I solve my problem like this, then I will just rotate my grid. I will just rotate my grid, this grid, the actual grid. I will rotate my grid by 90 degree. So that simply means that right now it is like this, 1 0 1 1 1 1. So I will write it like this then. 1 here, 1 0 1 we have, right? 1 0 1, and then 1 1 1. Okay, so if I'm going to rotate it by 90 degrees, so my 1 1 will come here, 0 1 will go here, and 1 1 will go here if I rotate it by 90 degrees, right? This is what's going to happen if I rotate it, right? And then again on this, I'm going to again call a method which is going to solve my problem horizontally. So horizontally means, now horizontally means like this way, right? And this simply means vertically only if I write it like this, if I see this example, original one, right? So I'm going to use the code of horizontal only to solve the vertical also, vertical case also, right? Same way, other scenarios also. So here in this part and this part 0 1, this one, okay, like this. If you see in this example, new one, if I draw like this, so 1 1, right, here we have 1 1, here we have 0 1, and here we have 1 1, okay, this case, right? So this is similar. If you see this is similar to this one, right? 1 1 here and 0 1 here and 1 1 here, right? Similar to this one, but here this time I'm doing it like this. I'm doing it like this, right? Okay, so here, from here we derive that why we need to rotate it. Okay, so because here I'm saying total 3 shapes, right? Here I'm saying that total 3 shapes. All right, so now, okay, why it matters actually, why I'm taking 3, right? So let's say I want to solve this one part. Okay, so here 0 1 0 1, right? This is what we have, right? So I know that I can pick my one part from here, I can pick my second rectangle part from here, I can pick my third rectangle part from here, right? If I divide it like this, so now I can shrink it now. Here 0 1 0 1, so first rectangle, if you see, I can shrink it like this only until here. Then I will take second, and in second, let's say I have one here only, then I will shrink it like this. Then in the third part, let's say I have 0 here, 1 here, 1 here, 1 here, so I will shrink it like this, right? I can shrink it like this. Okay, so let me prove it. Let's see if we can prove it here. All right. Okay, so this is, you have 1 0 1 0 and 0 1 0 1, right? So now I have told you 3 ways, so let's solve it, this original one, in 3 ways, right? So 1 0 1 0 you have here, and then here let's say 0 1 and 0 1 here. Okay, so now let's say you divide it like this. Okay, this first and this like this, right? So in this part you just pick this area, in this part you just pick this, in this you just pick this. Then what is the output you are going to get here? For this one, what is the length? So here if I give the indexing 0 1 0 1 2 3, right? So this is nothing but 2 minus 0 2 plus 1, so total length is 3 now. So area is nothing but 3 and 1, 3 3, right? Here 3, right? And for this part, one area, for this part, one area, right? So originally we start from here only, right? This complete, this complete, this complete, and then I have started shrinking, right? This is one way. Okay, now here we are getting 5, but if I rotate it by 90 degree, like this 1 0 1, here 0 1, if I rotate it by 90 degree, so here 0 1 will come, then 1 0 will come here, then your 1 0, this 0 1, then 1 0, then 0 1, right? And then 1 0, right? This is what's going to happen. Now if you apply the same thing, same logic here, right? Same logic here, same like this and like this, right? So if you try that, okay, so let's say you try it like this, maybe you pick this, okay, and then you pick it here like this shape, same shape, right? And like this. So in this you are just going to pick this, you can shrink this later on, so just one length. Here your length is going to come out as 3, right? And here your length is going to come out as 1, right? So 3 plus 4 plus 5, here also we are getting 5. But there may be some case, let's say, okay, so let's say here instead of 0, okay, here instead of 0 you have 1, all right? And if you have 1 here, that's it, means I'm saying that I have 1 here also, right? So now if you apply the same formula, right? Now if you apply the same formula, 3 here, 1 here, here you are going to get 2. You won't cover all. So 3, 4, 5, 6, then 6, right? But here only 5, only 5 is coming, still 5 is coming, right? Areas, rectangles, areas, still 5. But here now it is coming as 6. So that simply means that we have to check the grid both in original form and in rotated form. Okay, so I hope that this is clear, right? So once we did this, so from until now what we are clear with that we need to rotate our grid, and there are only these 3 ways in which we are going to make cuts, right? So one is like this, okay, so like this horizontally, so 1 2 and 3. One is like this one, and then this 2, and here this 3. Or one is this one, and here 2, and here 3. Then I can shrink this one, let's say I take it complete initially, then I can shrink it later on. Same way here 1 and 2 I can shrink it. Here 1, 2 and 3 I can shrink it. Okay. And if I rotate my grid, so then also I will just apply this horizontal formula. Okay. So I will check all these scenarios and don't go over these constraints right now, because constraint size is very small, very small for this problem. Okay. So I hope until now whatever I'm saying you are clear with that. Okay. This problem is actually hard, right? So no issues, we will make it easy, right? So now this is done. Okay. So now here, next thing, how we are going to rotate it, how we are going to rotate it. So we need to understand that logic as well, how I'm going to rotate the grid 90 degrees clockwise, right? So here, let's say I have this rectangle like this, and here this is one part. Okay. And like this you can say, right? All right. So that let's take a different number of rows and columns instead of 7. All right. So now here 0 1 0 1 2. Okay. So this is nothing but okay. So after rotating, what will happen? After rotating, I will get something like this. Okay. This is what I will get, right? So this is going to become my 0 1 and 2, and this is going to become my 0 and 1, right? Okay. So now here, let's say I place some values, 1 2 3 4 5 and 6. Let's say I place these values, right? So now in this, my n is number of rows is 2, and my m is number of columns, that is 3, right? So I'm going to create one rotated matrix, and in which my m is going to be the number of rows, right? And n is going to be my number of columns, that is 2, right? Then after that, what I'm going to do, I'm going to iterate. I'm going to run two loops: I is equal to 0, I is less than n, I plus plus, and j is equal to 0, j is less than m, j plus plus, right? Now here I have to fill this. So here, how I'm going to fill this? So this grid I and j, this value, right? This value. Okay. So if I rotate it, so first if I rotate it, then what are the values that I'm going to do? I have to rotate it by 90 degree. So if I rotate it by 90 degree clockwise 90 degree, so I will get my 4 here. Okay. 4 here, 1 here, then 5 here, then 2 here, then 6 here, then 3 here. Okay. So now this 4. Okay. So now here we have 1. Okay. Let's say this, here we have 1. So this value is coming from this position 0 0, right? So I can say this initially my I and j both are 0, right? Initially when I'm going to run my loop, my I and j both are 0, let's say. Okay. Grid I and j both are 0. So this value, I'm going to say that the rotated matrix that I have created, so in that, this j is 0 only, right? J is 0 only, and here I'm going to write in this position, I'm going to write n minus I minus 1. This is the formula that I'm going to use. Okay. So here j is 0, both I and j is 0, right? So here 0 0, here j 0, and here now n. Now here n, what is my n? N is 2. 2 minus 0 minus 1, that is nothing but 0 and 1. Rotated of 0 and 1 is nothing but 1. Rotated of 0 and 1 is nothing but grid of 0 0, right? This is the formula that I'm going to use for rotated. Okay. So let's do one thing. Let's write the code for this rotated part. Okay. So that I can prove it. All right. So here, private int, let me write it outside here. Okay. So private int, and here rotate 90. Okay. So this is what I'm going to give the name, and here we are just going to pass the grid, original grid, right? And now after this, inside this, just calculate the n value. N is nothing but grid dot length, and m is nothing but grid 0 dot length. And now you have to create one rotated, and here new int. Now this time you are going to pass m value here and n value here. Okay. This is done, and now you have to rotate it. So for int I is equal to 0, I is less than n, I plus plus. Okay. And here for int j is equal to 0, j is less than m, and j plus plus. Okay. And here, how you are going to pass this rotated? You are just going to do rotated. Okay. Here is equal to grid I and j. Okay, these are the values that you are going to pass, right? So here how you are going to pass that? So here if you have to write in this position you have to write just j. Okay, and here you have to write n minus 1 minus I. That's it. And this from here I'm just going to return rotated. Okay, so how I come to this j n minus 1 minus I? Okay, so that we need to check here, right? So uh here if you see in this position we are filling 0 by 0, right? If you notice this 1 and 1 here, so that means 0 by 0 value is coming here. Okay, and here 4 is nothing but 1 comma 0, 1 comma 0 is coming here, but actually it is 0 by 0, right? If you see this this 5, this is nothing but 1 1, right? And this 2 is nothing but 0 1. Okay, this 6 is nothing but here 1 and 2, right, in the original. And this 3 is nothing but 0 and 2. Okay, 3 is nothing but 0 by 2. Now here if you see uh, 2 and 1. Okay, 2 and 1. In this 2 1 I am filling 0 2. Okay, and here in 1 uh, 2 and 1, right? In same in 2 and 0 what I'm filling 2 and 0 I am filling 1 and 2. Okay, and here same way here in 1 0 1 0 I am filling what? I am filling 1 1. And here in 1 1 1 1 I am filling 0 1 value from original 0 1. Okay, and here same way 0 0 I am filling what? 1 0. And here in 0 1 I am filling 0 0 0 1 I am filling 0 0. Okay, so now from here you have to just derive the pattern how it is happening. Okay, so here if you notice one thing, we are rotating, right? So here if you notice in this pattern, this is 2 and this is 2 here, this is 2 here, this is 2 here, this is 1 here, this is 1 here, this is 1 here, this is 1 here, this is 0, this is 0 here, this is 0 and this is 0. So from here I derived that this value, okay, whatever j here, so same j I have to use here for the very first time. Okay, this is what I have derived first thing. Okay, this is how I noticed this thing. All right, and next thing how I noticed, so I noticed here that here we have 0, right? So here what we are taking nothing but the total number of rows that we have. Okay, total number of rows 2. In a 2 if I subtract this value, right, 2 minus I plus 1, if I do I am getting that. So this is how you have to actually check. Okay, so 2 minus 0 plus 1 1, here we have 1, so here we are taking 0, right? So this is how you can check. Okay, if you don't get the actual idea, so this is how you can drive that. Okay, since we are rotating 90 degrees, so just draw the diagram and then try to understand how we are feeding this rotated j, and here we are writing n minus I minus 1. Okay, so this is the one thing, right? So now here we have a rotated. Okay, so here let's say I'm going to call this, so I will say, okay, so I want to call this, right? So can I do one thing here? From here let's say I'm just simply returning 0, right? And in this let's say I call this, okay, rotate 90, and here I pass grid. Okay, I call this. All right, so I'm calling this rotate 90 and it is going to just rotate my grid, rotate 90 grid. All right, so now after that what I'm going to do here, I have rotated it, right? So now let's say I'm storing this in some, I just want to actually show, I don't want to do anything else here, I just want to show it how it looks rotated. Let's say here I'm calling this and I'm storing it here. Now I want to show it, right? So here you can do one thing, int, or I can do one thing here, let's take it m only, right? Int m is equal to, I'm going to read this, I'm just want to show how my rotated looks. Okay, this, and n is equal to grid. All right, here let's say 0 dot length, right? And now rotated, so I want to display this, so definitely my n and m will be changed now. Int I is equal to 0, I is less than n, I plus plus. Okay, and here for int j is equal to 0, j is less than m, and here j plus plus. And here I want to show it, so I will say system dot out dot print, and here I want to show this rotated okay, rotated, and here I will say show me this value ij. All right, and here space. Okay, and once this is done, then I just want to draw a line. Okay, so I will say system.out.print ln. Okay, and here I can just simply remove this, and here let's close it like this, and here let's say I draw this. Okay, so now if I run this, let's see what we are getting. So yeah, okay, ignore this. Okay, so see here, ignore the output. I just want to show this. So 1 1, then 1 0, then 1 1. Okay, same way if you see this test case 2. So here we are getting like this, uh, 0 1, then 1 0, then 0 1, and then 1 0. Okay, so that simply means our rotated code is working. Okay, so now let me just remove it. Okay, this is all not required. This is just for showing how our matrix looks. Okay, so let me just remove this. All right, and this is also not required here. Let me remove it. And here, from here, okay, so we are going to get some value from our original grid, and some value from this rotated grid, right? So I have to return the minimum possible sum of the area of these rectangles. Okay, so what I'm going to do from here, I'm just going to return math dot min of here. Let's say I'm calling one method solve, and in solve I'm just going to pass my grid, and in same solve method, okay, in same solve method I'm also going to pass rotated. Done, that's it. So this is our code for this part, right? And now in solve, what we need to do, that is the next question. Okay, so here in this part we are trying to solve an original grid, and it's a rotated version, right? This way we cover both horizontal and vertical partitions. This is the use of this one. And I have already written the code for this rotate 90 here. Now we have to write the code for this solve. Okay, so now in solve we have only these scenarios, right? This, that's it. Okay, so for this we need to write the code now, right? So here what I'm going to do, let's say from here only I'm going to start. Okay, so here private int solve, and in solve what I'm just passing the grid. All right, so first time I am passing this, that is original, and also I'm passing the rotated. So I'm just passing the grid only, matrix only, right? So here I can say matrix or grid, whatever I want. All right, and now inside this again do one same thing, int n is equal to grid dot length, and just copy this. Okay, let's save some time. This video is already going to become very lengthy, I think. Already taking a lot of time. All right, and here, all right, so now what is the worst case? What is the worst case? We have to turn the minimum possible sum of the area of these rectangles, right? Note that the rectangles are allowed to touch, and we have to form three, right? All right, so worst case is that when I form this one, and let's say this two and this three, okay, like this whole completes the original rectangle also, right? I'm not able to shrink these as well, so I cover complete area of this rectangle, right? So my worst case is going to be the number of rows into number of columns, that is the total area of rectangle. That is going to be my worst case, right? So here we have to find out the best, right? So in best, what I'm going to do, I'm going to pass the upper bound, worst case, that is nothing but n into m. That's it. All right, this is clear. Now after that we have to discuss the different cases, right? So case 1, case 1, that you can say your L-shaped partitions, right? uh, like partitions like this you are forming, like this, right? This partitions, or you can say this partitions, right? So let's say the L-shaped partitions. Okay, just I'm giving the name L-shaped partitions. Okay, because in these partitions also, if you see one big, we are taking then one here, all right, or like this one here. Okay, so let's say this is nothing but your case 1 L-shaped partitions. L-shaped partitions. All right, okay, this is done. All right, so now here what we need to do, so now for L-shaped, so again we have to iterate over all the rows and columns, right? Now I'm talking about L-shaped partitions. All right, so let's say this is my rectangle. Okay, here also there is one important case actually, that's why I'm drawing it. right? So here let's say these are the number of columns you have, okay, and these are the number of rows, like this, let's say like this. All right, so here I'm talking about the L-shaped partitions, right? So L-shaped partitions, I'm saying in L-shaped partitions also we have two cases, right? In L-shaped partitions also we have two cases. One is like this, and then this, and then this, okay, or one is this complete, and this, and this, okay. These are the two cases in my L shaped also, right? I can say that this is nothing but my top, right? Here this is nothing but my bottom left, and I can say that this is nothing but my bottom right, okay. In this case I will say that this is nothing but my top left, this is nothing but my top right, and I can say this is nothing but my bottom, right? So these are the two cases in L shaped, right? All right, okay. Now here let's, what we need to do, okay. So here we have to form three areas, right? Three areas. So I can take this as my top first, okay. This is what I can take, or I can take this, right, my top, or I can take this my top, right? If I take this top, then I can take my bottoms like this, right? These two parts, okay, like this, or I can also take it like this, okay. I can take like this, right? But I can't take my top like this complete, because if I take my top, this top complete, right, then where I'm going to fit this? Then I'm not taking three rectangles, right? So what I'm going to do for this top, right, I'm iterating over row wise, right? First this row, first this row, then next time this row, right? So I will stop here. Until here only I have to run, right? Until here only I have to run, okay, for my this row, right? Same way for column, I can take this as one, okay, this one as complete, okay, this may be the case, or I can take until here and then this one until here, or I can take this one until here and then this one until here. I can't take this complete bottom left until here, right? This is bad, because then where is my bottom right? This one, right? So this is how I have to write my loops, okay. So here, now see carefully how I'm going to write these loops. For int row is equal to 0, and here normally I write it like this, row less than n, right? This is how I write, but here I have to stop one hand before, right? So I can say row plus 1 is less than n, right? Or I can say row is less than n minus 1. This is also I can write. All right, so here row plus 1. Same way for column also I'm going to do the same thing. Col is equal to 0, col is col plus 1 less than m, and here col plus plus. All right, this is done. Now we have two cases under this, right? So one is I'm taking top here, then after that I'm taking bottom left, then I'm taking bottom right, okay. So now we are going to get some area, right? And that area is going to be area 1, that is area is going to be, so this area plus this area and this area, right? But I'm not taking this as complete area, right? Maybe if I take this, let's say, right, my top, so here only this one is here, so I will take the shrinked area, right? This shrinked area from this one also, right? Okay, so what I'm going to do, instead of simply writing this complete area, I'm going to call one method here also. So I will say that method as bounding box area. I have to pick the area in such a way that it covers all the ones in that particular area. That's it. I don't want to unnecessarily take the zeros also, okay. If this itself contains all the ones, then I don't need to take this one complete like this, okay. So bounding box area, right? This, all right. So now in this, what I'm going to pass, I'm going to pass my grid, right? And this upper part, okay, this part, this can be this one, this can be this one, this can be this one, right? So here what I'm going to do, starting from 0 and here complete, okay. So here 0 and row, right? Starting from 0 and row, and here you know that my row is stopping at row should be less than n minus 1, so my row is not going to take until here, right? So that's why 0 to row, 0 to 0, 0 to row I'm writing, right? 0 to row, so means 0 to 0, then 0 to 1, then 0 to 2, and that's it. I'm stopping, I'm not taking this. So here 0 to row, and column I can take complete. Okay, complete as area. In this I have to shrink na, right? So here I can say 0 to, now this complete. So here I can say this is nothing but m minus 1, right? So 0 1 2 3, so number of columns is 4, 4 minus 1 3, right? So m is the number of columns, right? M minus 1 is 3, right? So here I'm just going to write m minus 1, right? So this is for the upper part, this part. Okay, this part complete I can take, or I can take this until here, or I can take this until here, right? So this is what I'm doing here. All right, in this, whatever the value I'm going to get, in this I have to add. Now again I'm going to call this bounding box area. All right, bounding box area. Now inside this again I'm going to pass my grid, right? Now this time bottom left, bottom left. Okay, so we have this. Now I'm talking about this one. Okay, bottom left. So here this bottom left also, it is going to start from what, from where it is starting. So definitely this, it's not going to start, this bottom left is not going to start from top itself, right? Okay, so here let me just remove all this. Now I'm talking about bottom left. So my bottom left can start from here, right? But it can't start from here. Reason is because I need top also here. So here, so in my row I can say that it is going to start from row plus 1. Okay, and starting from row plus 1, and it can, if it is starting from here na, it is starting from here, it can take complete area until here also it can take, right? And this is nothing but n minus 1. So this to this I will check, then this to this I will check, then this to this I will check. Okay, so row plus 1 to n minus 1, right? This is how I'm writing here. And same way for call 0 to call, right? Simple, right? So column we can take 0, right? This and this, we can't take this last one because we need bottom right also. So that is my call, and call you already know that it is stopping at call is less than m minus 1. So 0 to call, right? Now same thing for bottom right. So again copy this same bounding box area, pass grid, and this time your row, what you are going to pass, you are going to pass here row plus 1, and here n minus 1, right? Okay, same like this, right? Row plus 1 n minus 1, both can start from same, right? Same, see, it is starting from here, it is also starting from here only, right? So it can start same condition, but for this one starting point is going to be different, and this ending point it can take complete until the last column, right? So here n minus 1, and here it is going to start from n minus 1, and it is going to start from call plus 1. Okay, call plus 1. Why call plus 1? It can't start from here only because we need bottom left. So it can start from here to here. Let me just remove everything again. So here it can start from here to here, or it can start from here to here, or it can start from here to here. It can go until here, right? So that is why call plus 1 to m minus 1, right? Okay, that's it. That's it. Okay, so this is how we are going to write this. Okay, let me just format the code. So this is how we are going to get area 1, right? Now this is for area 1. Okay, same way there is one more way, right? There is one more way, that is top left, and here plus top right plus bottom, like this. Okay, so same way, whatever the logic I have applied here now, you have to write the same, apply the same logic here. Okay, so here int area 2, let's say this area 2. So now top left will be there. So for this one you have to write 0 to row, and here 0 to call. Okay, 0 to call, and here you have to write grid. Here you have to write 0 to row, 0 to row. Okay, and here you have to write call plus 1, and here you have to write m minus 1, okay, and here you have to write grid row plus 1, and here n minus 1. Here you have to write 0 to m minus 1. That's it. Okay, so same way like here how I'm applying now, so you can just draw the same diagram, okay, for this one. So here let's take this scenario. So this can start from this, but it can't be take the last column, right? So that is why. And it can start from here. Same way for the rows, it can't take the last bottom one, right? Because bottom one is there for this one, right? So that is why 0 to row I'm writing, and you know row is stopping where, right? And 0 to column, right? And you know column where it is stopping, right? Very easy. Now same way for this one, it can't start from 0. It can only start from col plus 1, right? So in my column 0, so it is going to start from here, right? So if you see 0 to row, right, same condition for this, like this, but here column plus 1, and then it can take complete minus 1. Same way the last one, it can start from here, but it can't start from top, because we need this top left and top right. Okay, so that is why I'm saying row plus 1, then 2n minus 1, then 0 to n minus 1. That's it. Very easy, right? Clear this part? Okay, so now this is for L-shaped scenario, right? So whatever the best answer we have to get here, we have to write it here. Best is nothing but math dot min of best, and here math dot min of your area 1 and area 2. Okay, this is done. So this is for this scenario. Okay, L-shaped. Now case 2, that is 3 horizontal strips, right? So that's nothing but case 2. Okay, and here that is nothing but 3 horizontal and here strips. Okay, so here what you need to do, so that also very similar to this one. Okay, so let me just go back track here. Okay, so now you need to have two partitions like this. Okay, like this you can create, right? Or let's say you have one r1 and r2, right? So r1 can take this, right? R1 can take this also. If R1 is taking this, then R2 can take this, right? But R1 can't go beyond this, right? Same way, R2 can take this and R2 can take this also, right? Beyond that, it can't take, because then 3 will not be formed, right? Because we need 3, right? So this is the case that I'm going to apply here, right? So we have to write our for loop like that. So for int R1 is equal to 0, and here we know that R1, it should be less than n minus 2. Okay, or I can write r1 plus 2, right? Same thing. And here r1 plus plus, and same way here what we need to do, for int r2 is equal to, this r2 is always going to start from r1 plus 1. Okay, plus 1, right? And here r2, it should be less than your n minus 1, or you can write r2 plus 1 here, same thing, right? And here r2 plus plus. Clear, right? And now here again you have to calculate the area, right? So here let me just copy this int, let's say this is area. Okay, and here bounding box area grid 0 to r1, here r1, and here 0 to call, it will be complete. Okay, m minus 1. Same way here also, this grid, here you are going to say r1 plus 1, r1 plus 1, and here you are going to say r2, r2. Okay, so no, this 0, here you are remove this now, starting from r1 plus 1. Okay, and this is going to until r2, and then column you have to take 0 to m minus 1 always, right? Here also 0 to m minus 1, here you have to say r2 now. Okay, r2 plus 1, and here you have to say until n minus 1. Okay, so r2 plus 1 and n minus 1, and here 0 m minus 1. Okay, this is done, and then you have to update your best, this line, copy it. Okay, and here once you calculate this, then here you can write. Okay, so best is going to be math dot min of best and the area that you're going to get here. So here remove this. All right, so this is your best. So let me just format the code. Okay, this is done, and here your for loops and this for loop, and this is just going to return the best, whatever the best answer that we are going to get. Okay, so this solve method is going to return this best, right? Now here inside this we are using this bounding box area, right? This, so for this one, where it's very simple. Okay, it's not complex. So for this one we are going to use the same logic that we have written for part 1 of this. I think that was problem number 3195. All right, 3195. So whatever the logic we have used there, we are going to write that. Okay, so now let's write the code for this. Okay, so here private int bounding box area, and here what you are going to pass, you are going to pass your grid, and you are going to pass int u, int d, int l, and int r. All right, and now inside this int min row is equal to, so here in this bounding box area we are passing these three things only, right? 0 to row, then this. Okay, so we are going to compute the bounding rectangle area of all ones inside submatrix u to d and l to r. Okay, right? So min row here, you can say grid dot length, and here max row is equal to -1, and here min call is equal to grid min call. Here min call is equal to grid 0 dot length, and here max call is equal to -1. All right, so now I'm going to shrink it. All right, so how I'm going to do that? So simple code, int I is equal to u, I is less than equal to d, and here I plus plus, and here for int j is equal to l. Okay, j is less than equal to r, and here j plus plus. All right, and here I'm just going to check if grid of I and here j. All right, if it is equal to 1, then in that case we have to update our min row as min row as math dot min of min row comma I. All right, and here same thing, we have to update our min row, max row, min column, max column, right? So here min row, here let's say max row, and here min column, and here let's say max column. Okay, max column, right? And here also you have to write same thing now, max row, and here min column, and here also you have to write what, you have to write this max column. Okay, copy this, paste it here, max column, and here min row here II, and max column is, we are showing it with j now, so here I have to write j, and here I have to show j, right? And this is done. Okay, and here if no one's found, then we have to return infinite, right? Cost. So this partition is invalid, right? We have to form three rectangles, so if in any one rectangle, right? So here what I'm saying, if no ones is found, return infinite. All right, infinite cost. So this partition is invalid. Okay, so here I will say if max row is equal to -1, then return integer dot max underscore value divided by 3. Okay, and otherwise you have to return what, here how you apply, get the width and height. So simple now, max row minus min row plus 1 into here max column minus min column plus 1. All right, so now let's do one thing, let's run it, let's see if the code will try to fix that. So yes, there are some issues, we are getting wrong output. Okay, so we have to see where we are missing something. Okay, so here I want to take max now, so here I have to take max, right? Here I have to take max. So let's see now if we are able to pass all the test cases or not. So yes, all the test cases has been accepted, right? Now let's submit it and see. So see, our solution is accepted, right? Keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.